In this video, we're going to learn a new type of angle relationship that's depicted here in figure B. So if we're looking at the difference between figure A and figure B, hopefully you're kind of remembering that in figure A, this is an example of adjacent angles. And if you remember adjacent, that word means next to each other. So if we look here, we have angle ABD, and that's adjacent or next to angle DBC. We could get fancier than that if you wanted. You could say that they share a vertex, and the vertex here would be B. We could also say that they share that ray, and the ray that they share would be BD. So if we look at B, it's very, very different, at least the two angles that we're talking about, which would be angle JNL and angle MNK. Remember that vertex is listed in the middle. This time, the only thing that they share would be a vertex of N. They have no shared ray, and instead of being next to each other, they're almost across from each other. So we're going to learn more about those two angles in this video. The angle paired shown is called vertical angles, and vertical angles are formed by two intersecting lines. So if we look, that kind of X figure is really two lines that are intersecting. We have line LM and we have line JK, and they meet at that vertex of N. So vertical angles are formed by intersecting lines. The examples here, well, we have the two that are already marked for us of JNL and MNK. We could also look, there's really another pair of vertical angles, and that would be these two here. So that would be angle JNM and angle LNK. So what we're going to be talking about next is if we know they're formed by intersecting lines and we know they're kind of across from each other in those, how are their angle measures related? So the goal is to figure out how are vertical angles related. And we're actually going to take a step back and use our prior knowledge about complements and supplements to help us figure out how vertical angles are related. So if you look at the figure to the left, I have two intersecting lines, which mean I have two pairs of vertical angles. Let's start by knowing what we already know. If I look here, I have one angle that's 35 degrees. And if I first look at how that 35-degree angle is related to angle 1, I can see that those are supplements. Supplements add up to 180 degrees. So to figure out what angle 1 is, I can do 180 minus that 35 degrees. So that tells me that angle 1 has to be 145 degrees. Then I could kind of reverse gears, and instead of looking at 35 degrees in angle 1, I could look at 35 degrees in angle 3. Because if I notice, those are also supplements. So I know that those would also have to equal 180 degrees, which means angle 3 is also 145 degrees. Now for that last angle, angle 2 here, I could look at it a couple different ways. I could look at the relationship between angle 1 and angle 2, or I could look at the relationship between angle 3 and angle 2, because both of those form a supplementary pair as well. So this time, instead of using the 35 degrees, I'm going to be saying, well, 180 minus that 145 would give me what angle 2 is, and that would give me 35 degrees. So let's take a step back and let's see kind of what we just discovered. I have angle 2 ended up being 35 degrees, and angle 1 and angle 3 were both 145 degrees. So let's specifically look at the vertical angles. Angle 1 and angle 3 are vertical. Both of those were 145 degrees. Then I have that 35-degree angle and angle 2, which was also 35 degrees. So hopefully we notice that vertical angles are equal in measure. That is going to be important for us to remember. So then the question becomes, well, how can we use what we know about vertical angles to solve for missing values? And the thing to keep in mind is that when we see vertical angles, we are thinking that they are equal to each other. So let's look at example 1. I have a pair of vertical angles. One is represented by x, and one is 36 degrees. Well, we know that those two angles are equal to each other. So what that tells us is that x also has to be 36 degrees. Let's bump it up a notch. For example 2, we have 138 degrees is vertical to this angle that's represented by 23x. To start to figure out what that x would have to be, I'm going to first set those two equal to each other. So 138 is equal to 23x. The goal would be to figure out, well, what does x have to be for that angle to equal 138 degrees? So to solve that, I can divide both sides by 23, which gives me that x would have to be 6 in order for those two vertical angles to truly be equal to each other. In our final example, we're going to use that same mentality. I know that each vertical angle has to be equal to each other. So here I have that 125 would be equal to the 5x plus 30 angle. Notice I dropped the parentheses since nothing was really in front of them. It doesn't affect it. To solve this, I would first have to subtract 30 from both sides. So that leaves me with 95 is equal to 5x. My final step would be to divide by 5. And that would leave me with 19 degrees would have to be x in order for that angle to be 125. Now to find the angle, if you look, this means the measure of angle WOX. And if I look at where WOX is, that's right here. There's two ways to find this. I know that since they're vertical, it has to be 125, but we'll look at using our x value to make sure that we have the right answer. What I'm going to do is take that 5x plus 30, and instead of x, I'm going to substitute in our answer of 19. So I'm going to check, is 5 times 19 plus 30 really equal to 125 like it should be? Well, 5 times 19 is 95, plus 30 gives me that 125 degrees that I was looking for. So the summary of this is vertical angles are equal to each other. So when you're setting up and using vertical angles to find missing values, take your two angles and set them equal to each other. Good luck.